GeoGebra applet, two applets. So very quickly, we'll get to the first one. Here you have what we're going to call a whiteboard. And whiteboard is exactly that. It's a place where we can make notes, write, draw, sketch, and that's what we're going to do. So I'm going to walk you through the icons that you will use for this activity. The first icon that you can use is this, which is a pencil, and you can click on it, and then you can work on this area and sketch, draw, etc. So this is a sketching tool. And every time you want to erase or undo, you can come here, and this will undo the action you just did. So for example, if you notice, if I continue, it'll gradually erase this shape that I did last. Alternatively, you can also erase. And to erase, you will click on this eraser icon. Make sure that when you click any icon, the icon is active. In other words, you notice it's blue. And then here I can just use like an eraser. Okay, the second tool that you may need is this tool, which is a tool to sketch straight lines. So for example, here I click on it, notice it's active, and I can go from one point, click and hold my mouse, and then as I sketch it, the line doesn't appear straight at first, but then it corrects itself. So I could do something like that. So that's this tool. This next tool I'm going to show you is a segment tool, which is very similar to the one we just did before, except this segment tool, it draws straight lines. Now notice it's active, and I just click and hold, and I can draw segments, right? So maybe if I wanted to illustrate a vector, I could do something like this to illustrate the tail, and so on. Okay, so that's the segment tool. The next tool you might use is this, or you will use, is the text tool. And here's the text tool. Click on it, it's active. I can put my cursor anywhere on the screen, click on it, and then I have the opportunity to enter text. So let's say, for instance, that I am solving vector resultant using a cosine law. So my solution might look something like this. I can type the absolute value of vector r, the magnitude of the resultant, for example, equals, and then I can type my math. Let's say 4 square plus 5 square minus 2 times the cosine of 4 times 5. I can use the times like this, times 5. I can use the times with the asterisk, which is the uppercase 8, 4 times 5, or 4 times 5, or just the brackets. 2 cosine, oh, excuse me, now I'm looking for the angle. So I would put the angle, let's say the angle was 35 degrees. And that would be the magnitude square of my angle, of my resultant, excuse me. So I would type it like this. You can figure out that the little hat that is the uppercase 6 gives me the square symbol, and the rest is very transparent. So take a look at when I press OK. Now I have my formula here, and I can use the next icon, which is this arrow. When I click on it, I can move anywhere on the screen. So now I can move this on my screen. I can slide this a little bit, and that is part of what I wanted to type. Of course, I can always type it in another way with the other tool, with this friend. Yeah, and that's fine too. If it facilitates for you to do something like this, r square equals, oh, excuse me, whatever you find easier to do. Okay, you can literally use these as a note. Okay, even if it's not perfect, we'll understand, or a combination of both. Okay, so that's the tools for this applet. I'm going to use the erase tool to clear the screen. And then I'm going to show you the second applet that you may use in this activity. Alternatively, you can do the work for these questions algebraically on paper pencil and just show the key ideas that you use and the value. But I would, at a minimum, I would like to see what version of the sine law or cosine law you used. Okay, so now let's take a look at the next applet. This applet is very helpful. This applet helps us add vectors. And if you notice here, we have two vectors, vector with a head of C and one with a head of D. And the vectors here are shown with both at the origin. They are set up tail to tail. We can change the magnitude and direction of each of these vectors in any way we want. So for example, for vector C, if the magnitude was, say, 65, I can do this. And when I press enter, notice the vector got larger, and I can also change the direction. So I'm going to change this angle to, say, 20 degrees. Press enter. And if you notice, this is equivalent to a direction angle. So the 20 degrees is here, and the magnitude is 70. And let's say my second vector had a magnitude of 30, and the direction angle was, say, 185 degrees. That's what I would have. So this applet allows me to manipulate these vectors any way I want. And here's the most interesting part, that if I move this slider, this is going to show me a solution that is using parallel methods. So here, if we remember, when I move the slider, it tells me the angle between the vectors, which is about 165 degrees. Then the next step, it creates a vector parallel to vector C at the end of vector D. You can see that. And then is going to create equivalently a vector. Now the angle between the vectors here is 15 degrees. And there is my resultant. From this was similar to the parallelogram method or the triangle method, if you want to see it that way too. I had vector C at the end of vector D. Vector C at the end of vector D, and that is the resultant. That vector shown in green, and I also get the magnitude. And here's the answer. The magnitude is 36.85, and the direction is 32.17 degrees, and that's a direction angle, like we've seen before. So you can verify the answers to your work here after you answer the questions that are being asked. The other option is to show a solution using components. I'm not going to touch on that. I would let you explore it now or later. But that's it for this video. Thanks for watching.